All right, welcome to lecture number 8, the application layer, information systems. So today we're going to talk about software that helps you organize and analyze data. We're going to look at spreadsheets, database management systems, and information security. So spreadsheets, you guys have noticed spreadsheets is usually the Excel spreadsheet. They're a program that allows you to organize, analyze data using a grid of cells. There's 3 different components to a spreadsheet. You have text, you have data, and you have formulas. Texts are simple headings, data is usually numbers, and formulas are usually stuff like summing. So the functions inside of spreadsheets is almost like another programming language. One thing with spreadsheets you got to be careful for is called circular references. It's a set of formulas that ultimately and erroneously rely on each other to compute their results. For example, if we look at cell 1, cell A1 depends on the answer from cell B1 to resolve the equation and provide an answer. Unfortunately, cell B1 needs an answer from cell A1 before it can resolve the equation. This creates a circular reference. In 1978, Daniel Berkeley formed Software Arts to produce the first spreadsheet program called VisiCal. Because VisiCal wasn't patented, Lotus created its own spreadsheet and put VisiCal out of business. And finally, Microsoft Excel surpassed Lotus. So that's why you don't hear about VisiCal or Lotus as much, because Microsoft took both of them out. And because there's no patent on the process, anybody could create a spreadsheet program. Spreadsheets are good for tracking sales, analyzing statistics, keeping records, expense reports, and what-if analysis, and much, much more. Once a business becomes too big and they're ready to move from spreadsheets, they need to move to database systems. It's a structured set of data combined with software to retrieve and analyze data. It's a collection of spreadsheet-like tables connected together by relationships. Let's look at an example. Let's say we had a movie store, and we're going to create a database for a movie store. First table I want to create is the movie table. The movie table has movie ID, title, genre, and rating. And these are rows in this particular table. So for example, movie ID 101 is the movie Sixth Sense, genre thriller, horror, rating PG. Now these numbers here, the movie IDs, these are unique IDs. The words over here can be duplicated, but the movie IDs must be unique. The next table is the customer table. We have customer ID, name, address, credit card number. Here again, the ID numbers need to be unique. The things on this side does not have to be unique. And these numbers over here, these ID numbers, can be the exact same numbers, for example, as you see over here in the movie ID table. But as long as they're in this table, they're totally different. So in this case, in customer 101 is Dennis Cook. You see his address and you see his credit card number. The last table is the rents table. It is combined the customer ID, the movie ID, the date rented, and the due date. Now, the customer ID and the movie ID come exactly from the other 2 tables. So these numbers are from the other tables. And the only thing that's unique in this side is the actual date rented, and due date. So if I want to know who customer 101 is, I have to go back to my customer ID table and see how that person is. If I know what movie 103 is, I need to go back to my movie table and see what that is. The thing with databases is that you never want to repeat data. You want to write data one time in a database and not have to put it in multiple places. You want to look it up by their unique IDs. So for example, here's the relationship diagram of the particular tables. So the customer table has your name, your address, your credit card number, and customer ID, which is connected to the rents table. The rents table has date rented, due date, and movie ID, which comes from the movie table, which has title, genre, and rating. So this is the complete diagram of your database. Let's move on to information security. Information security is a set of techniques and policies enforced by an organization or individual to ensure proper access to protected data. There's confidentiality, integrity, and availability is what I want to discuss now. Confidentiality, ensuring that data is protected from unauthorized access. For example, you don't want just anyone to be able to learn how much money you have in your bank account. Integrity, ensuring that data can be modified only by the appropriate mechanisms. For example, you don't want a hacker to be able to modify your bank balance. Availability is the degree to which authorized users can access information for legitimate purposes. Information security has this field called cryptography. It's this field of study related to encoding information. The word cryptography comes from the Greek for secret writing. Encryption is the process of converting plain text into ciphertext. So you have plain text, you use a key, it encrypts it into a ciphertext, and that's the encryption process. Decryption is the process of converting ciphertext back into plain text. So you have the ciphertext, it goes through the decryption process, and on the outside pops the plain text. A cipher is an algorithm used to encrypt and decrypt text. The key is a set of parameters that guide a cipher. The substitution cipher, which probably is the simplest cipher, is a cipher that substitutes one character with another. For example, the letter A is substituted with the letter N, and the letter E, for example, could be substituted with the letter R. So you have this message called hello, but when it's ciphered, encrypted, it creates the ciphertext URYYB. Now this message is decoded based on this key to get the original message back. And this is called the substitution cipher. Now let me talk about public key cryptography. It's an approach to cryptography in which each user has two related keys, one public and one private. The first step is I take my public key and I give it to anybody. I take my public key and I give it to anybody who wants it. Then from my public key, they use it to decrypt their cipher. So they decrypt it, and then what I do is I take my private key and I decrypt the cipher to get it back. So anybody can have my public key. Once they lock their message with my public key, they can't get it back. Only I can get it back because I have the private key. And that is public key cryptography. And that ends our lecture today.